The last topic of our first unit is the principle of inclusion and exclusion. And we've already looked at this in the case of two sets, the simplest case. If we have two sets, then two sets A and B, and we combine them, put them together to make one set, that's what we call the union, then the number of things in that combined set is the number of things in each of them individually summed minus the number of things in the intersection, right? So this is where the inclusion comes in, is we've included the number of things in each set, but because some of those things are counted doubly, we have to exclude those that are counted doubly, and so they're just counted once in the computation. So the first problem we're going to do along these lines will also show us some other counting in a kind of a special case, I guess. I'm going to calculate how many integers there are between 1 and 881 inclusively, meaning we'd count 1 and 881 if they happen to apply. How many of those are divisible by 3 or 5? Now here, the divisibility by 3 or 5, the or here, is what means we're taking a union. Okay, that's the part that tells us that we're dealing with a union. So what we're going to do is count them individually first, just like we did up here, and then count them according to the number in the intersection. So we'll do that here in just a second. So first of all, the number divisible, I'll use this as a heading here, and we'll put by 3. So in order to count that, what I'm going to do is say, okay, it's significant we're starting with 1 here. That makes it easier to think about, because the first one is 3 times 1. The next one is 3 times 2, so there's 2 of them so far. On to the last thing that we would count would be 3 times n, where n is some integer, and not only that, n is, this is going to be less than or equal to 881. Okay, and in fact, not only is it some integer, it is also the biggest of these, the biggest that satisfies that property. Notice another way we can say this is that we have that n is an integer, and it's less than or equal to 881 divided by 3, right? If we take this expression right here. And so it's the biggest integer with this property. Well, that's what we mean by the floor function evaluated at 881 divided by 3. So that's equal to, if you actually do the calculation, that comes out to 293.6 continuing. So that's 293. When you're doing this, I would appreciate it if you would use the symbol for the floor function. I think it's good to get used to a symbol that has some meaning. And so here we have 293 is the actual value that we're going to count there. So how about by 5? Using a similar technique, let me go back to the green here. So by 5, we do a similar thing. Again, because we start at 1 here, we can simply take the floor function of 881 divided by 5, which turns out to be the floor function of 176.2. So the round down function, right? So we get 176 is the number right there. Now we're going to add those two. That happens to be those two numbers up here in the size of the sets A plus B. That's what we're adding those to. But we need to remove those that are double counted here. So each of these counts those divisible by 3 and 5. So we got to take that out of our count there. Now what does it mean to be divisible by 3 and 5? Well, it simply means to be divisible by 15, 3 times 5, because those are relatively prime. That's all we have to do. I'm not going to deal with the case where they're not relatively prime, certainly not at this point anyway. So here, divisible by both simply means divisible by 15, and that gives us the number 58.73 continuing. So that's equal to 58. So we get finally, the final result would be 293 plus 176 minus 58, and that is equal to the number 411. Now I want to do a variation on this, but we're going to use this number as we look at the next question here. So 411 is the number we got there. Let me just jot that up here to remind ourselves, 411. So now this question asks how many integers between 414 instead of 1 and 881 inclusively, meaning that we would count these if they're divisible, are divisible by 3 or 5. Well, you might be inclined to take the difference here, the subtract, and then do the technique that we did before, but that will not work, not in general. It gets the count off, and you will get inaccurate numbers doing that. So rather than doing that, what we're going to do is take those less than or equal to 881, and we already got that as 411, minus those less than or equal to 414, because in both cases starting from the count from 1 means it's easier, because you're saying 3 times 1, 3 times 2. You're just counting them all from 1 up to the number you need. But we'll do the same idea here now. So these right here, less than 414, what we'll do is we'll take 414 divided by 3 and take the floor function of that. So that's by 3. I mean divisible by 3 when I say that. And when I do that one right there, we get 138. You should check me on this. Make sure I'm telling you the truth. That's 138 by 5. We get 414 divided by 5 is equal to 82. And by both would be the floor function of 414 divisible by 15, or divided by 15, and that gives us 27. So in this case here, we get the final result for this as 138 plus 82 minus 27. And when you add that, let's see, the 138 and 82 is 140, and 80 is 220 minus 27, so that's equal to 193. Right, so let me go back to a better color here. Yeah. So that would mean then that we would have between 414 and 881, we'd have 411 minus 193 is equal to 211 and 7 is 218. I think I have that right. 218. Okay? So that's the answer to this one right here. Okay? So I'll probably give you some problems of this nature at some point for you to illustrate how you can work with a floor function and how you can work with the inclusion-exclusion.